Welcome back to Dev Errors Fixed. Today, recursion error, maximum recursion depth exceeded. Your function is calling itself, and Python finally throws up its hands after about 1,000 nested calls. There are really two reasons this happens. Your recursion never reaches its stopping point, so it goes forever, or it's correct but genuinely too deep for the call stack. We'll reproduce the classic version, a base case that looks fine but can't be reached, read the traceback and fix it two ways. Let's go. Here's the idea. A recursive function solves a problem by calling itself in a smaller piece, and it must eventually hit a base case, a simple input it can answer directly without recursing. That base case is the breaks. If the recursion never reaches it, the function Mokaku keeps calling itself deeper and deeper. Python doesn't let that run until your machine dies. It caps the call stack at around 1,000 frames and raises recursion error. So the error is really telling you your recursion isn't stopping. Look at our factorial. Its base cases: if n equals 1, return 1, call factorial of 5, and it steps down 5, 4, 3, 2, 1, hits the base case and unwinds. Perfect, but call factorial of 0. 0 isn't 1, so it recurses on -1. -1 isn't 1 either, so -2, -3, and it's walking away from 1 forever. The base case exists, but 0 can never reach it going downward. That's the trap. Not a missing base case, an unreachable one. Let's write it. A factorial function with a comment reminding us that 0 factorial is defined as 1 and 2 calls, factorial of 5 and factorial of 0. The body is empty for now. Let's fill in the version almost everyone writes first. Here's the natural implementation. Base case: if n is 1, return 1. Otherwise, n times factorial of n minus 1. It reads perfectly, and for 5, it's completely correct. 5, 4, 3, 2, 1, done. But look hard at that base case. N equals 1. It's an equality check. Anything that steps past 1 without landing exactly on it, like 0, sails right by and keeps going. The bug is hiding in a base case that looks totally reasonable. Run it. Factorial of 5 prints 120. Great. Then factorial of 0, and there's our crash. Read the traceback. The same line, return n times factorial of n minus 1. Previous line repeated 996 more times. That repetition is the fingerprint of runaway recursion. And at the bottom, recursion error, maximum recursion depth exceeded. Python hit its stack limit and stopped us. The traceback tells you exactly what to look for. First, factorial of 5 worked, so the function isn't wholly broken, it's an input problem. Second, one line repeating hundreds of times means the recursion isn't shrinking toward a stopping point. And the recursion error itself is just Python's safety limit tripping. It's the symptom, not the cause. The cause is always upstream. Which input fails to reach the base case and why? Recursion error has two flavors. One, the base case is never reached. A logic bug, which is ours, fix the condition so every valid input reaches it. Two, the recursion is correct, but the input is simply too deep, thousands of levels. No condition fixes that because the real limit is the call stack. There, the fix is to stop recursing and use a loop. Iteration has no depth limit. We'll apply both. The fix. First, change the base case from n equals 1 to n less than or equal to 1. Now 0 stops, 1 stops, and even a negative input can't run away. That one character equals to less than or equal kills the bug. And second, the bulletproof version for genuinely huge inputs, an iterative factorial, just a loop multiplying from 2 up to n, no recursion, no call stack, no depth limit at all. Two fixes, a reachable base case for the logic and iteration for depth. Run the fixed version. 0 factorial is 1. 5 factorial is 120. And the iterative one computes 1400 factorial, a number with 3799 digits, instantly without ever touching the recursion limit that would have crashed the recursive version long before. No error, correct answers. Both problems solved. Quick recap. Recursion error means your recursion isn't stopping or it's genuinely too deep. Don't fixate on the line that crashed, that's just where the stack ran out. Look at the base case. Can every input actually reach it? Make the condition inclusive, less than or equal instead of equals, so nothing slips past. And if the recursion is correct but simply too deep, convert it to a loop. Iteration never overflows the stack. A quick note, reproducing these errors and explaining the real fix takes real work. If it helps you, the wallets are on screen and there's a Ko-fi link below. Every tip funds the next one. Thank you. That's recursion error, maximum recursion depth, exceeded, reproduced and fixed at the root. The rule, the error points at the stack limit, but the bug is in your base case or in choosing recursion for something that should be a loop. Subscribe for a new dev error fixed every episode. Tell me in the comments which one keeps biting you, and I'll see you in the next one.